Hi everyone, this is Sean. Let's go through the first problem on exam. So for part A, we want to find the work, which is force times displacement. And the displacement here will be the distance traveled by the paddle, which is the arc of the circle, and it's in here. So for Lagrange equations, we know the work is equal to negative potential, and so we substitute that back to here. We get this equations. And we want to determine the kinetic energy. The total kinetic energy, which is equal to the kinetic energy due to rotational and translational. And rotational, we have to times 2 because we have 2 tires. Now, we know the relationship between the velocity of pedals and velocity of tires, and this will be the ratio. And so we can do a little arrangement, and we can define a new Lagrange equation. Now, there's a question why it is okay to treat work as a potential. It is because it's based on work energy theorem and conservation of energy. The work energy theorem says the work is equal to changing kinetic energy. And changing kinetic energy plus the changing potential energy is equal to 0. So if we substitute this into here, we get a new, which is the work is equal to negative changing potential energy. So now we want to apply for the Euler Lagrange equation to find the maximum or minimum. We take the derivative and with respect to time and phi, and the second derivative. And then so we can define a new Euler Lagrange equation in here. And we want to relate the angular acceleration to linear acceleration in here. So phi prime 2 can define as this one. We substitute back to Euler Lagrange equations. Now for part D, the force due to gravity and force equal to force equal due to the riders has to balance in order to keep the person inclined forward, upwards. This is because it has to satisfy that if no external force acts on the object will remain its inertial motions. And so we do a little arrangement. We torque, which equals the force times the radius, and then we found that the force is equal to mg times sine theta times r ratio divided by r. So for problem 3, first of all, we want to find the angular momentum. And so we do a little trick, and so we can rewrite d over dt as this here. Same logic, we find r prime, second prime, and we substitute u equal to 1 over r, and we can find r and r prime in the same logic in here. Now we substitute the radial equation of motion in here, and we write a potential effective with respect to u. Rewrite that here, and we substitute everything we found in here. So we can rewrite, we get this equations in here. Now for part B, we're going to find the central force. We know the relationship between force and potential. Here we have the potential, right? So we can actually rewrite, and so we can do that. And then now in here, and we also given the orbit, which is r equal to a phi. And then so if we do a little substitutions, we can actually found the force in here, which is from here. We can move these to the left-hand side, and integrating over that, we can actually find the force. Okay, so now we find the force. We want to find the potential, which is the same logic in here, but now it's also integrating over that. And because this is indefinite integral, so we have the constant in here. Now we want to find the total energy in here. So total energy here, we have r prime, which r prime is we found in problem 1. So r prime is actually in here, right? R prime, we have r prime in here. And we also have r prime in here. And also we know the angular momentum is here, and so that way we can actually cancel out the m in here. We substitute that, we can define the phi prime, and we substitute r prime, phi prime, and potential we found in here. Rewrite that, and we also want to, in this part, we need to rewrite that, which is due to these relationship, and so a squared over r fourth. And we do a little arrangement. We know that these two are identical but opposite sign, so they cancel out. So left with only the c constants. So what's that mean? So that's meaning the energy is conserved because energy equal to a constant no matter the path. So thank you so much. See you.